let's take a look at a certain particular example to explain the illustration of Coulomb's law. Now you see under superposition, if you want to find the resultant force, that's the addition of all the forces, if they are much. This is just two charge now. You can apply normal Coulomb's law. You have your F equals to your stuff, so you get your answer instantly because it does this with only particular two charges. There are no extra charges whereby you now start looking for the net force. Are you getting what I'm saying? So at that point now, what I just want to try to explain is, I told you guys that the force that they are exerting, the charge that they are exerting force on is the one that is being called the test charge, and that test charge is the one that is being able to move anywhere, while we assume the source charge to be at a fixed position. So if you look at now, let's say you have two positive charge particles fixed in place on the x-axis. This is the diagram. It says the charge 1 is 1.60 times 10 raised to power minus 19. So we know it is a positive charge because there is no negative at the front. So we know automatically it is a positive charge. And charge 2 is also a positive charge. And do not forget, from normal, what do they call it? Your normal law. You all know that positive charge, your like charges, whenever you have a like charge, that's charge that have the same, the particular particle that have the same charge, let us put it that way, they will repel themselves. Now positive and positive now, they will repel themselves. Whenever you have negative and negative also together, they will repel themselves. They will move away, they can't attract. But if it's unlike charge, let's assume that is, if you have positive and you have negative, they would what? They would attract themselves. So just put that in your mind. This is thing that we already understood before. Positive charge, they will repel. If they are together, that is, them just in a short. Unlike charge attracts, while like charge is actually what? Repel. So from this aspect of thing, the question now asks us that the particle separation, the distance between charge 1 to charge 2, that's what we call particle separation, is 0.020 meter. So that is the distance between both of them. Now the question asks, what is the magnitude of the electrostatic force? That's the magnitude of F12. The magnitude of electrostatic force on particle 1 from particle 2. That means the force is acted on which particle? Particle 1. Don't forget, that means particle 1 is what? Is our test charge. That means this is the one that is free to move. Either moving like this or moving like this. Are you getting my way? So at that point now, we are looking for what? The particular force, which is what? Force F12. Are you getting what I'm saying? Which is unknown. So at this point now, charge 1. We have charge 1 to be equals to what? 1.6 times 10 raised to power minus what? 19 coulombs. Are you getting what I'm saying? So at this point now, we have charge 2 to be equals to 3.2 times 10 raised to power minus 19 coulombs. So this is the particular two charges that which you are taking out. Then to find force 1 to now, like I told you, and our distance R is equals to what? Is 0.020 meter. So applying Coulomb's law, the force 1 to now would be equals to K, right? And the absolute value of charge 1 and charge 2 over distance with what? Between charge 1 and 2. So this would be equals to, what is our K? 9 times 10 raised to power 9, right? Times what is charge 1? You have 1.6 times 10 raised to power minus 19. Then charge 2, you have times 3.2 times 10 raised to power minus 19 over our distance, which is 0.020. Are you getting what I'm saying now? So by breaking our particular value down, we are going to be having our charge. Now if you look at what I'm doing here now, you would see that this point, let me even remove this vector so as not to get confused. This point, you are looking for normal value of the force itself. The force value. Now after you've looked for the force, then you now check out the vector force. Now the vector force you are looking for, this is the normal force you get. The vector force you are looking for is the one that will now tell you, or you now consider that this force 1, 2, that you search or you get, is it in the positive direction or the negative direction? So let's solve our value. Now if you have to solve your value now, you have f12 now automatically. Your f12 is equals to without not wasting our time, you have 1.15 times 10 raised to power minus 24 Newton. This is our value for it. But because we know that this force is much more like a vector quantity, so if you want to get the main magnitude of the vector total sum, which we know that is actually talking about only the individual force here. So if you want to get the force 1, 2 now, with respect to the vector, the direction, you have to come back to the diagram to consider the diagram. Then you look at now, we know that what? You have to check out that when charge 1 meets charge 2, what will happen? Because of they are both positive, they will repel. Abi? That means that the force, if charge 1 wants to come and meet charge 2, it will repel itself. And it can't repel itself towards charge 2, it's not possible. It will also move its own sideways. And you know charge 2 will not move away from where it is because it is at a fixed position, it's a source charge. So charge 1, when it moves away now, it will move away towards this particular side. And on this s-axis now, we know this side is the positive s-axis, this side is the negative s-axis. That means that the force that is being imposed in these two particular charge pushes charge 1 towards which side? The negative side. So that means that the value that you get here, in terms of the vector value itself, that's the magnitude of force 1, 2, it will be equals to what? Negative 1.15 times 10 raised to power minus 24 Newton. What direction? The opposite direction. Are you get what I'm saying now? So that is a little example that we can use to illustrate some little information on what we need to understand. Alright, let's take a look at this particular example. You see, all these things are quite easy if you are used to the logic. And the question says, a charged triangle. Consider you having 3 points, charge 1, charge 2, charge 3, at the corner of a triangle as shown below. Now you have charge 1 value, you have charge 2 value, you have charge 3 value. With the aspect of view, even without telling you that this is negative, you should know since the value is negative here, charge 2 is automatically negative. Now, there's 2 things that you need to understand in this particular question is, you might be asked to find the electrostatic force of the magnitude. And both they saying find the electrostatic force of that certain particular magnitude of the value. And they saying find the resultant force on this charge is still the same thing. That means you are going to find the magnitude and also the direction at which it moves. So the moment you have more than just one charge, the other one we consider is just a single force between just 2 charge. Now this one you're having 3 charge now. You have to find each relationship between one particular charge at which it exerts on it and the other one at which it exerts on it. Then you now add them together to find the total resultant force. So if you look at the question asks that find the resultant force on charge 3. That means that since you are looking for the force that is pushed into charge 3 without you not thinking too much, that means charge 3 you can see here is our what? Is our test charge. That means charge 3 that you can see here is the one that can move around. I get what I'm saying. So at this point now in space, now listen to something. Let me tell you guys something. Don't stress yourself at all. Whenever a particular charge repel yourself, I guess I'm saying, whenever a particular charge repel yourself at a certain particular degree, you don't need to think of finding anything or any direction or assigning any sign. Okay, does it move in the negative direction or the positive direction? You don't need to. The moment it is at a particular certain degree, don't worry, I will explain what I'm saying better. Now, it says that we are looking for the components, the magnitude and the direction, whereby the theta is 37 degrees. Now, this degree that I have been given now, it is actually at a particular certain point that we need to check out. Now, if you look at, we have to think. We know that the resultant force is on charge 3. That means charge 1 will exert force on charge 3 and charge 2 will exert force on charge 3. Then we have to find our, what do they call it, the magnitude of the force on 1, 3 first. And that will be equals to what? K. And that will be K, absolute value of Q1, Q3. And then the distance from 1 and 3. Don't forget, please. So our K is what? 9 times 10 raised to power 9 times, what is your charge 1? You have 6 times 10 raised to power minus 9. Then times, what is your charge 3? You have 5 times 10 raised to power minus 9 over, what's the distance from 1? The distance from 1 to 3 is what? 5 meter. So that is 5 square. Oh, sorry. This is R13 square. So sorry. There are some 1 or 2 little things I've also said under this while explaining the Newton, what do they call it? The second example. So please, this is distance square apart. So sorry for that. Now you have 5 square. So you have F13 being equals to. Now while we are calculating this, you can punch your calculator and break it down yourself. Because of time, we don't have time. So we have 1.08 times 10 raised to power negative 8 Newton. That's the value for our F13. So to get, we've gotten our F13 now. So to get F12, the same thing is applicable to it. You have K, then Q1, Q2 over distance from 1 to 2 square. Are you with me? So from there now you have 9 times 10 raised to power times 10 raised to power 9. Then times, what is our charge 1? Now this 6.0 and 6 is the same thing. That was why I omitted the 0 that was at the front of them. Okay, so there's nothing that is new there. So you have 6 times 10 raised to power minus 9. Then times. Now I told you guys something about absolute values, that if you are finding their normal value, their normal force magnitude, whenever they have this absolute value, I mean, it's always been telling, it always tells you that even though charge 2 is negative here, so far there is absolute value. This, you are not going to write negative 2 times 10 raised to power minus 9. You are going to be writing a positive 2 times 10 raised to power minus 9 because of the absolute value. Please put that back in your mind. So distance from 2 to 3. We've gotten 1 to 3, Abby. So we are actually dealing with the charge on 3. So that means distance from 1 to 3 and 2 to 3. So charge from 2 to 3. So the charge from 2 to 3 now, we are going to be having, if you have to break it down, distance from 2 to 3, so you have charge 2 times charge 3. So sorry please. So charge 2, which is on this, then times charge 3. So sorry guys. So you have 9 times 10 raised to power 9 times charge. No, this is some distance 2, charge 1 acting on charge 3, charge 2 acting on charge 3 also. So it is not 1, 2, it is 2, 3. From there now you have from charge 2, we have, which I've explained to you before, 2 times 10 raised to power minus 9, then times 5 times 10 raised to power minus 9 over the distance from 2, 3 square. You have, what is distance from 2 to 3? You have 4. So that will give us some 4 square. So you can use your punch your calculator and break it down very well yourself. That will give us 5.625 times 10 raised to power minus 9 Newton. So we are not yet done. This is just like the part 1 of what we are looking for. We've gotten the magnitude of 1, 3 and 2, 3 now. So what's the next step that we have to check out? The next step that we are checking out is based on the component. So let's try to check out, write the table and explain some things to ourselves under the component. Alright, so when you look at this now, whenever you are considering the vector, now this is the part 2. After the part 1, you find the magnitude of, even though you have been given like 4 charges, whatever you just have to do is find their magnitude first using Coulomb's law. Then from there, you now look at the vector you are dealing with. If you look at now, our vector that we are dealing with is from the vector force we are dealing with is force on 1, 3 and force on 2, 3, right? And it has become a vector now. So you have vector force of 1, 3. Put the direction at the top. And vector force on 2, 3. Are you with me? So, or let's say we put 2, 3 first. Just 2. 1, 3 here. Let's say 2, 3. Are we there? So, how do I know the degree that 1, 3 will take? How do I know the degree that 2, 3 is going to be considered? Now, listen attentively. When you talk about S component of some certain things, S component is dealing with the horizontal level. If you are someone that is not familiar with mathematics, just put that back in your mind that X component deals with a cos theta value. Y component deals with a sin theta value because the vertical aspect. Are you getting what I'm saying? So how do we know the degree that the vector f13 would be assigned to? Now come back to here. We want to look for the direction of f13. So that is how we are going to know what kind of degree is going to be assigned to it here. Are you getting what I'm saying? Now if you look at now, we all know that we are being given a certain particular degree, which is 37 degree. That 37 degree is either this force that owns it or this one. So we want to know which one actually has this 37 degree. Now let's check out force 13 now to know, because I told you guys that if you are dealing with vector, you are dealing with direction. To know if the value, the f13 you got, is it going to be a negative value for it or a positive value for the f13? Now moving on to whatever we are dealing with now. 13, I told you guys this is the charge that is moving. Now this is two positive charge, which means they will repel themselves, and they are not on horizontal level. Unlike the other one we did that time, those ones are on horizontal level. It was quite easier to quickly know that this will go in this negative direction. Are you with me? Now, whenever you have a particular charge 13 at this point, which are not moving in a certain manner, if it's not in an horizontal manner, whereby you would be able to quickly detect that okay, this is also negative, this is positive. If charge 3 attracts charge 1, you know it won't attract it. Charge 3 will be moving away from it. But you know charge 1 can never move because it's a source charge. It will stay fixed here. So charge 3 will move away from it, and the direction at which charge 3 will be moving away will be like this. It will be this direction. Are you getting what I'm saying? And this direction now is with respect to the horizontal. Are you getting what I'm saying now? So at this point now, that means that they are meeting at a certain particular angle. They are meeting at a certain particular angle, and that angle is what we consider to be what? The 37 degree. That angle is what we consider to be what? To be 37 degree. Are you getting what I'm saying? So at this point now, that means that we know that the force, the movement of the force, the resultant is going to be f13. And how do I get this horizontal? You might be wondering, how do I get horizontal and how do I get vertical? You know, this is under Pythagoras theorem or under right angle triangle. Since this is a resultant, you know it is a resultant on its own. Since this is a resultant, you should know that under resultant, there have to be horizontal component of the resultant and vertical component of the resultant. So that is why we consider this point now as the horizontal component and this point as the vertical component. And since this point is the horizontal component, that means that I'm going to be having f13 cos theta here. But that is not really necessary like that, because we are going to specify whatever I want to do here. And since it already has horizontal and vertical component, there has to be a degree here. So that means that the degree at this point here is being owned by f13, which is 37 degree. That means f13 owns 37 degree. f13 owns 37 degree. Are you getting what I'm saying? And it will have s component like we said, and also it will have y component. That's f13 sine theta, vertical, horizontal. So at that point now, that means that f13 now, the s component will be what? f13, value of f13 cos theta, and the y component will be what? f13 sine theta. You don't need to consider, like I said, you don't need to consider signs whenever it is not in an horizontal level that you need to check that is it going this way, negative or positive. You don't need to consider the sign. Just write your normal value of your normal force. But if you look at now, charge 2 and 3 now, at this point now, we are looking for the charge on F12. Now if you look at F23, why am I writing F12? F23 rather, Jerry. So if you look at F23 now, you see that there is an attraction between them. And if I tell you this one is the fixed charge because this is the resultant we are dealing with, that means that it's positive that will come and meet negative here. That means positive will be going through this direction. And think a little bit. If positive is going to this direction, what kind of direction is positive going to? Think for some minutes. Do not forget in example 2, I told you that this side is a positive, this side is a negative direction. So for Q23 now, the force that would be in between them would be a negative vector force. That means that negative will multiply the value of the vector force you have. And if you look at now from our value, what do we have? We have F13 and F23, right? So let's deal with the F13 first. Now if you look at now, you will see that since they attract together, when a particular thing attract together, they come together. At that point, they have come together. Is there any degree between them? There's no degree at all when they come together. At times, even if they go in opposite direction, you can still have a negative degree, a 180 degree. But since they have come together, coming together of a particular man is a union. So at that point, it has 0. It has 0 degree. Are you getting what I'm saying? So that is the degree for F23. So F23 has what? Has a 0 degree. So at that point now, when you look at this, and like I said, it will be the one we are going to be assigned direction to, because this one we can see clearly that it moves towards the negative direction. Are you getting what I'm saying? So at that point now also, we are going to be considering 2 parts for F23 also. Even though it doesn't have a vertical aspect, you have to consider like as if it also has. So we are going to be having negative, don't forget, F23 cos theta, and also negative F23 sin theta. Are you getting what I'm saying now? So please put that back in mind. Now from there now, F13, what was our value for F13? That's 1.08 times 10 raised to power negative 8. That will be 1.08 times 10 raised to power negative 8 times cos what? Then we need to times cos 37 degree. Are you getting what I'm saying? So from that point, you have, whenever you break down your values, you have your answer. So as not to waste time. Now this, you have F13 cos theta here now. So this becomes 1.08 times 10 raised to power negative 8 sine 37 degree. Are you getting what I'm saying? So like I said, when you do your calculation very well, you should get your answers. So as not to waste our time. Now for the 0 degree now, you should know that we are dealing with negative aspect now. So now, you know that our F23 before is actually 5.625 times 10 raised to power minus 9. So since negative has entered now, we are going to be having what? Negative 5.625 times 10 raised to power 9 cos what now? What degree is assigned to 23? Cos 0. Are you with me? Cos 0. So negative 5.625 times 10 raised to power 9 cos 0 degree. The same thing is applicable to you also. Negative 5.625 times 10 raised to power, is it 9 or negative 9? Yeah, times 10 raised to power negative 9, not just a 9, negative 9 sine 0 degree. So when you calculate this, the answer you get, you put it down here yourself. Whatever answer you get also here, you can break it down yourself now. You break it down yourself. Now, what we just have to do now again is that we need to get the summation. Are you get what I'm saying? So we get the summation of all the force applicable to x. So this is one force of x now, one force of x, another force of y, another force of y. So we get the total, that's totality. What's the addition of everything? The total summation of the force on x and the total summation on the force on what? On y. So from there you have summation of force on x directly, so as not to waste our time. That means you add this force 1, 3 together with force 2, 3. So when you add them together, that will give you total force on the x component that you are going to have. So you have this now, cos 0 should be 1. So that will be the value you get here minus this. So you have your total addition of force x. And total addition of force x will be giving us 3 times 10 raised to power negative 9 Newton. And the same total addition on force y would give us that would give us 6.5. You have 6.5 times 10 raised to power minus 9 Newton. Why does it give us 6.5? So we proceed with breaking down of value. So you have this as 6.5 times 10 raised to power what? Times 10 raised to power negative 9. So moving on to breaking down aspect. This is the part 2 that we need to know. We've gotten summation fx and summation fy. Now don't forget that what we are looking for is resultant force of F3, Abi. And we know that if you are being asked to find resultant force of F3, this is a triangle. And just like we say in a right angle triangle. Another point now, since we know it's a right angle triangle, what do we say? We are still going to apply what we call Pythagoras theorem, don't forget. So we are looking for the resultant force of F3. That means from Pythagoras rule tells us that what? Resultant square is equals to what? X square plus what? Y square. Are you with me? So it's just like you saying this particular point like this. Are you with me? So this is just like you having the net force F3. So whereby this is the summation of the total Fx, that's the horizontal force, and this is summation of all the what? Total vertical force. So if you want to get the F3 square, you apply Pythagoras theorem. The total F net, that's F net means also resultant force. The net force also means resultant force. So you have this as applying Pythagoras theorem, you have this. So we want to find our net force from there with the logic we just introduced. Because being a right angle triangle, we can apply Pythagoras theorem to get our net force. So to get our net force now, you have net force on 3 would be equals to square root of summation of fx square plus summation of the fy square. So from there now we know the net force would be equals to, are you with me? Now the net force will be equals to what is the summation of fx square that we got, so that will be square root of summation fx is what? 3 times 10 raised to power minus 9 raised to power 2 plus the fy 6.5 times 10 raised to power minus 9 raised to power 2. So if you break it down very well, you have to come down, multiply this square, multiply this. When you break it down very well, let's break it one more step. So you have square root of, this is just 9 times 10 raised to power negative 18. You have 9 times 10 raised to power negative 18 plus 4.22 4.225 times 10 raised to power negative 17. Are you with me? So therefore our net force, this is the value for us. So you see the part 1, I've done part 1 to find the magnitude. Part 2 we table the components. Then part 3 we are looking for the main, what we are being asked to find now, which is the resultant force. So part 4 is now when you are being asked to find the direction. So we have 4 things to find in this category in terms of breaking the component down by finding the normal values, the normal force using Coulomb's law. Then you have the components, you have the magnitude, then you find the direction. So and we find the resultant force also. So from there now the resultant force will be equals to 7.16 times 10 raised to power negative 9 Newton. So these are part 3 now. We've gotten our resultant force. So the last one we want to do for today is finding the direction. Now how do we find direction? Let's see. Now when we are talking about direction means find the degree. Now you know we find the resultant force. Now you have to make sure that even you have, just like you're talking about what do we call it, under vector components, under what we call the orthogonal vectors. So after you find the magnitude, or we call it the resultant of the net force, you have to find the direction. Now what's the direction that you have been able to find? The theta. That's the direction at which the particular vector moved. So at that point now, if you look at this diagram now, you know we have our fy component, we have our fx component. So we have to consider that now you have opposites and you have adjacent. So at that point, you know that to find our degree, we are going to be having tan theta being equals to fy over what? The force fx. Or you are saying summation fy over summation fx. It's the same thing. Are you get what I'm saying? So therefore now your theta would be equals to tan inverse. Whenever you are looking for theta, the tan comes to this place and it becomes a tan inverse of our summation of fy, that's of 6.5 times 10 raised to power minus 9 over summation of fx 3 times 10 raised to power minus 9. So at this point our theta, when you break it down very well, should give us 65.2 degree. So that is all under this particular exam proof. So please like and subscribe. Thank you so much.